Hi friends, welcome back to my channel ABC Code. Last session we have discussed about how we can implement multi-threading by implementing run methods inside thread class. We can implement the run method in two ways, by extending the thread class or by using a method as an argument for the constructor of thread class. We have also seen how we can run two methods concurrently in two separate threads. Also explained why concurrent and why parallel execution is not possible in Python threading. In this session, we'll be discussing about how we can use and update shared variable while the same variable is being used by multiple threads concurrently. Let's start. I think till now there is no doubt. Now we'll be moving towards shared variable. For that, what I'm doing, I'm creating a class. Okay, let me do one thing. Say I'm creating a result here. It is a global variable, right? So, or much better or comfortable will be let's create one class with these two class election. Okay, I'm creating one class election and def init self dot result equal to 0. For an example, here the result is 0. Okay, and not actually a result. I'm saying that as of now, lion is the king. Now I'm setting lion result is 0. If the lion's result is okay greater than 0, that means lion is again lion has won. Otherwise, lion has failed. As well of self. Now how lion will fail? The intention is that all the lion will vote for lion, but tiger will vote for tiger. So that's the intention. We have 10 tiger, we have 10 lions. Okay. Now here, this is tiger, and what it will do? It will, this is tiger, and in this thread, it will do self dot lion result minus equal to 1. It will reduce the count of lion's result. And lion will actually what it will do self dot lion result plus equal to 1. So so you can understand that intentions is that lion will be increasing its results, try to increasing its results, and tiger will be decreasing the lion's results. So here we have same count of lions and tiger, so expecting that no one will win, a result will again 0. But if any tiger votes for lion, then lion will win. So here it is not the situation. So I'm giving it. Now the thing is, we will see the result. What is happening? Let's see here. Okay. Before that, we have to create an object of election equal to election, and we will do e dot. Sorry, e dot. Right. So these are the thing is happening. So here we are creating one thing, that main portion of this module. If name equal to main, then will be executing all this thing. So I think here you do not have any confusions till now. So let us run that and we'll be starting these two. The thing is, we have started T1, we have started T2. Now if we print the result, if we print the result, that E dot line result, then we may not get the correct answers. Okay, because these two threads we have started, but we are not waiting that two threads to be completed. What it does, as I have told you last time, if we start it, it's directly come back to main thread and it will just spawn another thread. And here again the thing, it will not wait that threads to be completed to execute the next statements, right? So here, if we execute this thing, then let's see what is actually happening now. Okay, let me print this way. The election result is format. Okay. Now let us run this thing. So you can see that where this statement has been printed, you are not seeing that because as I have told, before the execution of all these things, that statement has been executed. See, the election result is 1. So it is printing the result before completion of the election. In between election, it is start returning that yes, the result is this. So this is not good. So what we have to do, we have to wait for the election to be completed, right? Both the two. So that's why we have one method is called join. That way we are actually making sure that both the thread has been completed. So let us run. Now we can see the election result is 0. Now we can understand that yes, 10 lion has been voted, 10 tiger also voted, and final result becomes 0. Okay, so there is no problem here. Now let me create problem. So here is seems that while we are doing this thing, the result, this action, while one thread is actually manipulating this result, another thread may manipulate this result, but as it is doing too fast and CPU is not that busy, so this action is being working as an atomic action. That means here you can see this statement is actually what? This statement we can define in this way. It is actually store the value of self dot result. Okay. Then it increases the count of t plus 1. Okay. So t minus 1. And finally, this is the whole statement, right? These statements can be divided in this way. And finally, this result will be allocated to self dot lion result equal to t. So these are the three statements are being executed, but it since it is a atomic executions and no one is interfering in between. But if it happens that it has stored the lion's result and in between tiger comes and updated the result, then again lion has this result and finally lion calculate and lion update the lion result. Lion update the result with the with whatever value it has before to that value. That means there is an interference in between these two actions. Here the thing is what I will do, I will incorporate one small sleep time. So point 0.5. So point okay, point 0.5. I think yes, point 0.5 is needed because number of thread is very less. So number of actions in the part thread is very less. So I'm introducing a small sleep period such that this is the time which is needed by one lion to do its election. The same thing is for it is for tiger. Okay, same thing I'll be doing for tiger and lion also. Okay, so I'm doing this thing. I'm introducing a small sleeve here. Here actually it will hit plus one and then self dot lion result will be T. Okay, now see one thing. I'm first of all I'm reducing this. I'm removing this slip. Okay, and I'm also removing these statements because this was very much in atomic. See, this thing can be reproduced by increasing the number of these number in the range. If you can increases the number here or like 10,000 or 1 lakhs per 1 lakhs tiger, 1 lakhs lion, in that case, the CPU will be very busy and it will try to do context switching even if it gets a very small amount of interval. Say, variable assignment is being done such that it can give us a feel like things are running in parallel. So here we are just showing mechanically how it actually happens. So here we can, as a result, we can do the calculations well. So here let us run this thing again. See here we can see the result is 0, right? Now if we give a time slip, let's see. If we give a time slip, now you can see that CPU has some time, and in between what happens? See, the election results become 4. I did not make any manipulations into the calculations. The same calculations was there, but I have just introduced one sleep time such that CPU can get some small idle time such that it can do some context switching in between these atomic operations, which was actually previously working as an atomic. If we increase the range to from 10,000s to 100,000s, then what will be happening? The actions to be performed by CPU huge in number. It will slash the thread with a more smaller unit. As a result, in between these operations of adding and subtracting the lion results, it may switch contexts. Okay, so these situations will be happening. Now, how we can avoid these situations? Now, let's run this again. You can see it will be giving another result. So now it is showing 0, luckily. Now it is showing 4. Yeah, the number is very less, so we are getting, so here it is saying -2. So now we are saying that results are inconsistent. This situation is called race conditions. And how we can handle these race conditions, we'll discuss in the next sessions. So I hope it was interesting and see you again in the next session.